Hello everyone, in this tutorial we'll have a look at the conversion of recurring decimals into fractions. We'll take two examples, the first one with only one recurring digit and the second one with two recurring digits, and we'll see how this difference affects our method. So let's rewrite the first number here with the recurring digits appearing. We get this 0.2 and an endless sequence of 7, and let's call this number x. Now we'll try and multiply x by a suitable power of 10 so that the recurring digits will line up. So here, because we only have one recurring digit, you'll see that it's quite easy. Let me show you this. You might see that if you take this number and you multiply it by 10, you're going to shift all the digits by one place to the left. Here, you can notice that all the recurring digits that remain here will actually cancel out in the subtraction. So this number here was actually 10x, and we are going to subtract this x from the 10x that we have here. So all these recurring digits here subtracted from these ones will make a 0, and now we need to subtract this 2 here from the 7. We get a 5, and we subtract the 0 from the 2, we get a 2. So we see that the result of this subtraction is it's 2.5, and this was 10x from which we've subtracted the x here, so this is a 9x. Then you see that x can be written as 2.5 over 9 if you divide by 9 on both sides. If we make this here fractional writing a real fraction, it means that we can't have a decimal number like we have here. So let's multiply by 10 the numerator and the numerator just to convert this thing. And we get x written as a proper fraction here. It's 25 over 90. This fraction can be simplified if you divide by 5 numerator and denominator, and you can write it as 5 over 18. You can also notice that we could have straight away converted the first one into our final answer by multiplying by 2 numerator and denominator. You can now use your calculator and type 5 divided by 18 to check that the decimal value of this fraction is 0.2 with the recurring 7. Let's now have a look at the second example here where we have two recurring digits, and let's see what we need to change in our first method to convert this recurring decimal into a fraction. So here is our number that I'm still calling x, and it's 3.58686 repeating. You can see now that if you take this number and you multiply it by 10 like we did before, we have a problem because, you see, the recurring digits here that are lined up are not equal. It's because we had two recurring digits and we've only shifted everything by one place to the left. So the trick here is to shift it by one more place, and here you see that everything nicely lines up, and in the subtraction of this number here from this one, all this part here with the recurring digits is going to cancel out. So let's carry on this subtraction. We first have to notice that this number here has been multiplied by 100 to give this one, because we had to shift everything by two places. So this new number here is 100x. If we carry on with the subtraction, you see that this part here will cancel out. And now if you subtract the 5 from the 6, you get a 1, the 3 from the 8, you get a 5, and here we still get this. The decimal point is right here. So we see that this subtraction gives us 355.1. It was a subtraction of x from 100x, so we can say that this number that we have here is 99x. Therefore, you can write that x is 355.1 over 99. Once again, we can multiply everything by 10 to convert this into a fraction with only whole numbers. So it's going to be 3,551 over 990. This fraction right here cannot be simplified, it's already in simplest terms, so you can leave it like this, and you've converted this number here, this recurring decimal, into that fraction. Once again, you can take your calculator and work out the decimal value for this fraction to actually check your result. So you see, in this conversion, you have to see how many recurring digits there are in these numbers. If there is one recurring digit, you will need to multiply your number by 10. If there are two, by 100, and if there are three, by 1,000, etc. And then, once you've done this, a suitable subtraction here and there will enable you to get rid of the decimal part that you had right there, and this will help you find the correct fraction here, to which your initial number was equal. I remind you that, you see, it's this x we're after, because we called this number here x in the first place. Well, I hope this helps. Get ready now for practice. You can now try to write any decimal with recurring digits, and just make up your own. The two that I've chosen were random, and you can always use your calculator to check your results. So really, any recurring decimal will do. Experiment, take different numbers of recurring digits, and see if you can do it. Good luck!